corrective lens is a lens worn in front of or on the eye, mainly used to treat vision issues result from the eye's inability to focus the image onto the retina. In the normal eyes, the lens of the eyes bend the light to the right length for it to focus on the retina. The closest distance at which eye can focus clearly is called near point, which is normal is about 25 cm. The farthest distance at which the object can be seen clearly is called far point, which is normal is at infinity. However, some people's eyes have vision problems, so corrective lenses are designed to help the eyes focus incoming light directly onto the retina, thus producing clear vision. They work by bending light to move the focal point of the light coming into the eyes closer or further away, depends on the vision problems.
There are few problems that use corrective lenses as the one treatment. So I will explain the three problems that use the corrective lenses. The first is hyperopia or long sightedness. Long sightedness causes the incoming light ray to focus beyond the retina due to the shortened eyeball. So for the long sightedness person, they can see off into infinity, but they can only focus on objects that are distant away from them. So to correct the long sightedness, contact lenses are prescribed to reduce the distance in which the light will travel to accurately focusing on the retina. Second is myopia or short-sightedness. The myopia is a reflective error that causes the incoming light ray to focus in front of the retina as a result of elongated eyeball. So for someone who is short-sightedness, they are likely to have a near point that is even closer to 25 cm. So this due to the fact that the nearer the object, the more focused the image can be visualized. So to correct the short-sightedness, contact lenses are prescribed so that it can increase the distance in which the light will travel to focus it on the retina. Last but not least is astigmatism. The astigmatism is a reflective error that causes the light to focus it on multiple points, causing the blurred visual at any distance. In order to correct the problem, cylinder lenses is required to create a multiple focus point. So this will allow the image to land on one single point instead of multiple points, so it can be a clearer image.
For nearsightedness and farsightedness eye, we can use the thin lens equation. We now obtain an equation that relates the image distance to the object distance and the focal length of a thin lens. This equation will make image positioning faster and more accurately than doing ray tracing. 1 per focal length equals to 1 per object distance plus 1 per image distance. This is called the thin lens equation. Okay, for nearsightedness, formula of diverging lens. Negative 1 per focal length equals to 1 per object distance minus 1 per image distance. And for the farsightedness, formula of converging lens. 1 per focal length equals to 1 per object distance plus 1 per image distance. For converging lens, the image distance can be positive or negative. So when the image distance be positive, the image is on the opposite side of the lens. This is called real image. And for the image distance be negative, the image is on the same side of the lens. So this is called virtual image.
Here, this is example for the nearsightedness. Okay, based on this question, we can get the object distance must be equals to infinity, and then for the image distance must be negative 28.5 cm after 30 cm minus to 1.5 cm, and then we can use this the thin lens equations. We can get 1 per f equals to negative 1 per 28.5 cm, and then the focal length is must be negative 0.285 meter. And for the power of the length equals to 1 per f must be minus 3.5 diopter. the minus sign indicate that it must be a diverging lens. The unit for the lens power is the diopter, which is an inverse meter. 1 diopter equals to 1 meter power of -1. Okay, next example for the first sightness. Based on this question, we can get image distance equals to -98.5 centimeter, and then for the object distance equals to 23.5 centimeter. And then we can using the thin lens equations. We get 1 per f equals to 1 per 30.86 centimeter. And then the focal length we get 0.3086 meter. And the power of the lens equals to 1 per f must be plus 3.24 diopter. This plus sign indicate that it is a converging lens.
There are many applications of corrective lenses in our daily lives, but three main types of corrective lenses are eyeglasses, contact lenses, and intraocular lenses. Eyeglasses are corrective lenses that are worn on the face a short distance in front of the eye. There are several types of glasses, primarily the regular monofocal glasses, bifocal, trifocal, and the progressive lenses. All types of glasses need to be cleaned regularly with a microfiber cloth and a cleaning solutions. The next one is contact lenses. Contact lenses are placed directly on the eye's surface and almost invisible when worn. Contacts comes in several types, which is the disposable, the daily wear, the extended wear, and the continuous wear. Most of the contact lenses need to be cleaned and stored in a sterile environment when they are not being worn. Unclean contacts can encourage or cause problems with the eyes, including eye infections or even blindness. Last but not the least are the intraocular lenses, which is implanted into the eyeball and commonly used to replace the eye's natural lens that has been removed due to cataracts or glaucoma. Since intraocular lenses are not removed, they do not require care once they are in the eye, but the recovery period after the lens is implanted is usually about 2 to 3 weeks. That's all from us. Thank you.